Hello everyone, in this video I will demonstrate how to observe the BH hysteresis curve using a digital storage oscilloscope. This experiment helps us understand why magnetic materials lose energy and how that loss appears as heat. The apparatus we will require is ferromagnetic core or transformer core, primary coil, magnetizing coil, secondary coil, hysteresis loop tracer, and a digital storage oscilloscope and connecting wires. So what is the basic idea of this hysteresis loss curve? Practical is the magnetizing current produces magnetic field strength H. Then the induced voltage in the secondary coil represents flux density B. We convert electrical signals into B and H and display them on DSO. Now let's connect the circuit. Connect the primary coil with AC supply and secondary coil with integrator circuit. Now the X channel of DSO will be connected to proportional H and Y channel of DSO will be connected to proportional to B. Now let's set DSO to XY mode. We can choose XY mode from acquire, press acquire, then here we can see XY mode, then press here for the switch on of XY mode. In XY mode, the DSO plots one signal versus another instead of time. This allows us to directly observe the BH curve. Here I have set the DSO to XY mode. Now I will adjust voltage per division and center the trace. Okay, so this is the knob for adjusting the x-axis. By pressing this, here you can see the x-axis is moving, and for y-axis I will press this knob, and here you can see it is going upward. While adjusting x gain for h-axis and adjusting y gain for b-axis, we will center the waveform. Now you can clearly see a loop forming on the screen. Here I have traced the loop from the screen. This closed loop is called the hysteresis loop. At the top here you can see the saturation point, and in the middle you can see linear region, and at residual point you can see from B to O the retentivity, and the opposite field is coercivity. This is OC is coercivity and OB is retentivity. The loop is formed because B lags behind H. This is hysteresis. The area inside the loop represents energy loss per cycle. This energy is converted into heat in magnetic materials. Just like friction causes heat in moving parts, magnetic domains resist change and produce heat. If we increase the from here, the loop will become wider, meaning more hysteresis loss. For soft materials, the loop is narrow, so losses are small. Okay, so why DSO is better than CRO? Comparing to CRO, DSO provides better stability, storage, and precise measurements. We can freeze the waveform and analyze it easily. Thus, we successfully obtained the BH curve loop using a DSO and studied hysteresis loss. This experiment helps us understand transformer losses and material selection in electrical machines. Okay, so hysteresis, in short we can say this is a lag of B behind H, and area of loop is energy loss per cycle, and DSO in XY mode gives BH curve. Soft materials give small loop, and therefore we get low loss. Okay, so the idea of hysteresis comes from the work of James Alfred Ewing from late 19th century. He discovered that magnetic materials do not respond instantly to a changing magnetic field. They show a lag which is called hysteresis. An electrical system developed, especially transformer engineers noticed that transformers were heating up even at no load. Energy was being lost in the iron core. This led to the question, where is this energy going? It is lost due to the hysteresis in magnetic materials. To study this effect, scientists and engineers created the BH curve experiment to visualize magnetic behavior, to measure energy loss. Earlier, when it was done using a analog CRO, which is called cathode ray oscilloscope, but now it is done using DSO because the reason is it is more accurate, can store waveform, easier to analyze. This experiment is widely used because it helps understand core losses and transformers, compare magnetic materials, design efficient electrical machines. Hysteresis laws practical originated from the study of magnetic materials by James Alfred Ewing, and it was developed to understand energy losses in transformer cores using the BH curve. So here arrive some terms related to this experiment, which is magnetization. Magnetization means creating magnetic effect inside this core, and saturation is at this point the saturation point occurs when B reaches maximum value and cannot increases further. It is called saturation. Now what is retentivity? When current becomes zero, okay, but some magnetism remains, it is called retentivity. And what is coercivity? The reverse magnetic field required to make B zero is called coercivity. So the practical observation from this practical I got, when I increase the input current, the loop becomes wider. This means hysteresis loss increases. And the material type important for these concepts are soft magnetic materials have a small loop, so they have low loss. And hard magnetic materials have a large loop, so they have high loss. So this is how we study hysteresis loss using a DSO. Thank you.